Hi, and welcome back to today's lecture. Today we are going to cover sections 7.3 and 7.4, really discussing how we can add and subtract rational expressions. Now, these two problems that I'm going to cover in the next couple moments are not actually on your notes. However, I'm using these problems to tie back some earlier concepts to really help build an understanding for rational expressions. That being said, if I were to give you a problem such as 1/4 plus 2/4, the question is, how would you add these fractions? Well, the first thing is you have to have the same denominator, and in this case you do. Both denominators are 4, so they're exactly the same. And then I just add my numerators going across. So I'm going to have, for this first problem, 3/4. So again, I had to have common denominators, and then I could add my numerators going straight across. The same thing would be true if you had subtraction. Now, in the second problem, I have 1/7 minus 4/5. Ooh, I don't have the same denominator, so how do I do this? I have to get to a common denominator value. Now, I chose two numbers that are prime, and I did that on purpose for this problem. But to get a common denominator between 5 and 7, I would actually have to multiply this second problem by 7/7, the first problem by 5/5. I'm multiplying by 1 in either case because I'm not actually changing the problem, I'm just simply manipulating the values. So what do I get when I get this multiplication? 5/35 over here minus 28/35. Hey, now I have common denominators. So I have 5 minus 28, which is going to be a negative 23. Ooh, that's a 3. I'm going to write that up here. And that's over 35. Okay, so concept-wise, if I'm dealing with rational expressions or if I'm dealing with fractions, I have to have common denominator values to be able to add or subtract, which means in some cases I may have to do a little modification. I have to do a little work to rearrange. So let's erase this and jump into our first problem. There we go. Our first problem is c over 5a plus 4 over 5a. So I have two rational expressions. I'm adding them. Do I have common denominators? Yes, both are 5a. So I could literally combine this. So it is c plus 4 over 5a. And that is as simple as it gets because I do not know the variable of c. So I cannot do anything else here. That is just c plus 4, which is what my original statement was saying as well. Let's try another one. Say I have 5x over x minus 3, and I am subtracting x minus 1 over x minus 3. Again, first things first, do I have common denominators? Yes, x minus 3 is common. So I'm going to have a denominator of x minus 3 in my result. Now, notice very carefully that the second rational expression has a numerator that is expressional. It's not just a single term, it is expressional, it has multiple pieces. So what I'm going to do is I'm going to take my 5x minus, because I am subtracting, and then I'm going to put parentheses around my numerator here. So that's x minus 1. Why am I doing that? Well, this negative will actually change my signs. So I don't want to lose that sign change when I'm translating into one single rational expression like so. At this stage, I do need to simplify though. So I have 5x. This is going to be a minus x because I would distribute this value. So it would be 5x minus x, which is 4x. And then that's double negatives because again, you're distributing. So that's negative and negative. So that is a positive 1. And I have not changed my denominator value. So I have 4x plus 1 over x minus 3. Now, everything is great when you're working with common denominators already. However, sometimes you don't necessarily get common denominators. I'm going to do these next two problems over here. So I have 7 over 5x, and let's say I have another one, which is 6 over 15x squared. Now, I'm not adding or subtracting in this instance or the next problem. What I'm doing is I'm simply looking to see what would be a common denominator. So I'm trying to figure out how I would get that common value. Well, in this case, I have a 5x. In this case, I have a 15x squared. How do I go from 5x to 15x squared? Is there anything that's common between them? Yes, absolutely. Technically, this 15x squared, if I were to think about it factored for a moment, would be a 5x times a 3x. Interesting. So if I were to think about this term factored, that's a 5x and a 3x. Well, I have a 5x over here. What am I missing? I'm missing that 3x value. So I can multiply this side by 3x over 3x. That would give me 21x over 15x squared. This term did not have to change, so I have 6 over 15x squared still. Now, if I were adding or subtracting, I could now combine these because they have like terms, common denominators, making them like terms. Let's try another one. So I have 7x over x plus 2, and my second rational expression is 5x squared over x minus 2. That is an x. I'll make sure that looks like one. There we go. Now, looking at my denominators, is there any way I could factor those down? No, that's as simple as it gets. So, is there anything common between them already? No, because remember, this is an entire expression. When I'm talking about something that's common between two different terms or multiple terms, I'm looking at multiplication. This is addition, this is subtraction. There is no multiplication there right now. So, this is x plus 2 as a denominator. This is x minus 2. The only way I can get something common is if both of these have the other. So that means this would have to be multiplied by x minus 2. This would have to be multiplied by the x plus 2, which then means this is 7x squared, distributing, minus 14x over the x plus 2x minus 2. This side would have been 5x cubed plus 10x squared over x plus 2x minus 2. So if I were to combine these, they do now have the same denominator value. Okay, let's put this into practice. Let's say I have 3 over x minus 1 plus 5 over x minus 4. So I am now adding two rational expressions. They have unlike denominators, and so I'm trying to figure out, what is my common denominator between these values? Well, is there anything common as a product between these already? No, those are as simple as it gets. I can't factor them down at all, which then means I need to multiply this side by x minus 4 over x minus 4 to get a common denominator. This side by x minus 1 by x minus 1. Very good. Now, I have 3x minus 12 once I distribute here for my numerator value over x minus 1, x minus 4, plus I have 5x minus 5 once I distribute these values, and I'm over x minus 4 times x minus 1. Now notice, I wrote this as I saw it, x minus 4, x minus 1, right? But this side I said x minus 1, x minus 4. Does it matter? No. I did that intentionally just to make that point. We're talking about a product here, so these are still common denominators because you can multiply in any order. Okay, very good. My next rational expression that I'm going to get will have that common denominator. So I'm going to go ahead and put it down here. I'm going to look at what I have. I have 3x minus 12 plus, just as a good habit, I'm going to put parentheses around this one just to make sure I don't lose any signs. So I have plus that 5x minus 5. I'm not changing any signs, so I'm actually good here, which is great. So just combine like terms. So I have 3x plus 5x is 8x. Negative 12 plus a negative 5 is a negative 17. There we go. And so you would have 8x minus 17 over your common denominator value of x minus 1, x minus 4. Now, technically, at this point, you would want to ask yourself, can my numerator factor? If it can, I suggest factoring it out to see if anything can cancel. 17 is prime, so it will not factor out, and so there is nothing that you can do from this step forward. But that is something that you want to keep in mind as you continue to work on these problems. Okay, let's try another. Let's say I have 7 over x minus 3 minus 9 over 3 minus x. Those denominators look awfully similar, but they're not exactly the same. Why? What could I do here? Technically, I'm looking at this. This is a positive x, this is a negative x. This is a negative 3, this is a positive 3, right? It's almost like they're opposite of each other. So check this out. Could I factor a negative 1 out from this second denominator? Sure. Technically, if I did, I'm just going to do the factor right under as a shorthand note. If I did factor a negative 1, then that becomes a negative 3 and a positive x. I'm just going to write that as x minus 3. Hey, my denominators are the same. And you know that negatives can float, meaning with a fraction, with a rational expression, the negative could be in the bottom, could also be in the top, or you can carry it out to the side. I'm going to carry it out to the side. This makes a negative times a negative positive. That's 7x minus 3 plus 9 over x minus 3. Check that out. Now, at this stage, I have 7 plus 9, 16, common denominator of x minus 3. And there I go. Now, some of you might be still looking at this problem and saying, wait, go back to this. What did you do? I'm going to show you how to handle this another way as well. So, same exact problem, just rewriting it for us. If I were to factor a negative 1 out of here, then that's technically that negative 1 and then x minus 3, which is our shorthand note that we made right here. So I'm no longer looking at this value. I'm looking at negative 1 times that x minus 3. Now, what if I took this negative and gave it to the 9 instead? How does that change my problem? Well, I have 7 over x minus 3, nothing's changed here, minus, that would be a negative 9 now, over x minus 3. So all I did is I took that negative and I just moved it up, that's all. Common denominator of x minus 3. I have 7 minus a negative 9. 7 minus a negative is like 7 plus, right? So 7 plus 9 essentially is 16. Same exact thing, two different ways of looking at it. So either you can move this negative and change the addition or subtraction sign that you have out here to the opposite, or you can take that negative and apply it to your numerator. If you apply it to the numerator, make sure you apply it to all terms of your numerator for that particular fraction. Okay, very good. Let's try another. I am on example 3 at the bottom of the page. I have 3 over 2x squared plus x minus 2x over 6x plus 3. At this point, what I'm looking at is I have two denominator values that can be factored out. So let's go ahead and start factoring. I'm going to use a little bit of shorthand here. So my shorthand notes, I'm just going to factor right under these values instead of having to rewrite the problem every single time. You can absolutely still do that. It's still good form, but I'm just going to use a little bit of shorthand to help us out. So I have x that is common here, so I can pull out x, and I'm left with 2x plus 1 once I factor this. So I'm no longer looking at this, I'm looking at this as my new denominator, that x times 2x plus 1. Over here, I can pull out a 3, and I'm left with 2x plus 1. So again, no longer looking at this one, I'm looking at 3, 2x plus 1. What would be my common denominator? Well, they both already have a 2x plus 1. That one has a 3, this one has an x. Okay, so it looks like I need a 3 over here, so I'm going to multiply by 3 over 3. It looks like I need an x over here, so I'm going to multiply by x over x. Very good. So I have 3 times 3 is 9. Then this is 3x, 2x plus 1. Notice I'm leaving this factored. That's perfectly fine. I've done that all throughout, but some of them have already been very simplified already. But I'm going to leave this factored on purpose. Okay, this side. So I have minus 2x times x is 2x squared over, I have 3x, 2x plus 1. Okay, great. Let's go ahead and combine our like terms here, combine our fractions, so I have the same denominator. And then I have 9 minus 2x squared. Can this factor? No, so leave it alone. If it could factor, you would then be able to see, because you left your denominator factored, you would then be able to see if you could cancel anything out. Okay, so let's move on to our last example. Make sure I got some board space here. All right, let's say I have 1 plus the rational expression of m over m plus 1. What is my common denominator? That's an interesting one, right? This is 1. So technically 1 is anything over itself, isn't it? So what if this 1 was actually m plus 1 over m plus 1? That's still 1 because it's something over itself. But now, do I have common denominators? Yeah, let's use it. So I have the common denominator of m plus 1. Up here I have m plus 1 plus m. So just writing that out so we can see it. Combine like terms, that gives me 2m plus 1 over m plus 1. Is there anything that I can cancel here? No. These are not exactly the same, so you cannot cancel. You can't factor anything else out here, so you can't even factor them to see if there is something to cancel. That is it. That is all you get. Okay, ladies and gents, that is all for sections 7.3 and 7.4. I'm going to continue into section 7.5 here momentarily, or as soon as you click play.